Hey, hello, my young friends. How are you today? So, how are you doing at school? What interesting things are you learning? Are you preparing for a lot of exams? And I want to know what are you doing in Scratch as well? Are you doing something interesting, creative, crazy? Okay. Today our video is going to bring these two worlds together: school on one side and Scratch fun on the other. How? We are going to do something about with using the topic of trigonometry. Now, trigonometry is a subject that is usually introduced around between the 8th to the 10th grades here in India, at least. And it is a topic which is some kids find it difficult. Some kids find it easy. For me, trigonometry was not a very difficult subject growing up, but I could never see trigonometry in action. I always felt, even though it was not that difficult for me, I always felt, why am I learning trigonometry? Is there ever in my life that I'm going to use trigonometry? Or what is the use of this whole thing? Even if not me, but if someone else is going to use trigonometry. So I hope this video is watched by parents as well, because many times parents feel that the whole idea of Scratch is to have fun and coding and all. It has nothing to do with the curriculum subject. So I hope any parents watch who are a bit interested in how coding can intersect with school studies. Please do watch this video. And if you like it, then please like, share, and subscribe, like as usual. To start with, coming back to the question of why trigonometry is useful, I'll tell you a little story. So imagine there was a war going on, World War II, or maybe India-Pak war, or some war going on, or maybe the Russia and Ukraine war. And then suppose there is this group of Ukrainian soldiers, what they call a battery or battalion or whatever. So a battalion of Ukrainian soldiers is trying to, because they are defending themselves, they're not doing anything wrong, I would say. So they are trying to attack a very big Russian army, like what same battalion has made its camp near a hill. Now this troop is very small, and they're thinking, how can they get their own, how can they attack this particular group, how can they get reclaim that land. Now so one of a very strong big guy uh, in the battalion, in the company or battalion, or whatever these terms are, I'm not very clear about them. So he comes up with an idea. See, hey, Major, he's captain or major. I have an idea. We have a lot of grenades. Somehow we've got a lot of grenades from the area, from whoever that, from the Turkish people, etc. And why don't we climb up the hill, and we will rain grenades down on them. And even though we are a small, and then whoever is left will shoot them all down. And we'll that way, even though we are just 50 of us and they are like more than 500, then we'll still win the battle, because one grenade will take out like 5 soldiers, and whoever is left will be injured, and we'll just take them out with the guns. So the captain said, yeah, that's a brilliant idea. That's an excellent use of so many grenades that we are carrying on our backs. We'll quietly climb up the hill and rain down the grenades on them. Now there was a little meek, a geeky kind of a soldier wearing glasses, spectacles, and he said, sir, but what if the grenades explode well before they reach the Russians? So the big guy said, how can you say that? How can you doubt my idea? The distance is not that much. The grenades will surely fall down. They'll go really fast. They'll fall down, and they will all explode when they reach the ground, not in the air. And because if they explode in the air, then it will only alert the Russians towards the Ukrainians, and they will take them all down. So what this guy did was, he said, "Do you know how much is the height of the hill?" So the big guy says, "How can I know? How can I even know? But I know it's approximately this much and that much." So the little geeky guy said, "But approximate and exact, there's a very big difference." And there the major said, "Yes, there's definitely a major difference. You cannot be approximate in a war. Either you do something right or you don't. Either you're dead or you're alive. There's nothing in between. So if you do it right, then you're alive. If you do it wrong, then you're gone. So better be precise about everything." But then everybody thought, how can you actually measure the height of the hill without actually climbing it? Because once you climb it, then the Russians may be alerted, right? You cannot climb it. You have to be on this side of the wall and still get the height. So this little geeky guy who was very good in trigonometry in school, he said, I have an idea. I will just calculate the height of the hill based on the shadow. That's all. I just need an instrument called a sextant. So the major said, yeah, we'll just get the instrument from the neighboring company. Yeah. So he got somebody to get this thing. And when the sun was out, so I'll just show how he did this thing. And this is also a lot to do with how the Greeks and the and all those, the very intelligent people societies that existed before us, they discovered a lot of truths, a lot of facts about how the universe works, how the planets rotate around the sun, etc., using this kind of a knowledge called trigonometry. Okay, so I'll give you an example. So here, suppose this is the hill. Okay, and what this guy did was, okay, now let me draw in a different color the shadow. That is shadow that is falling down. Oh, why is it? Okay, so suppose this is the shadow. So what the little geeky guy did was he went and stood up to this point. Okay, and then he pointed the sextant up, and then he was able to find out the angle between this particular angle. I'll just draw it out. Now, based on this angle, he said this angle is 33.555 some degrees. Now, based on his knowledge of trigonometry, he said that this height divided by the height to the base of the foothill should be somewhere around whatever. You just take a random number for now, don't worry. So this ratio would be something like 20. No, sorry, 1:1 is 45 degrees. So if it is 30, this one is going to be a little more. So I'm just coming up with a random number. This is going to be around, this is divided by this. So it is going to be less than 1 for an angle of 30 degrees. So it will be somewhere around, wait, just let me give me a second to think about it. So tan of 30, I can actually just find out what tan 33 is. Tan 33. No, this is in radius, degrees. So 0.64. I was not too far off, like just about half or something. But how would you know that tan for 33.5 or something is 60? Because there are tables for that. Because it does not change. The ratio of the height to the base remains exactly the same. It does not depend on the height or the base of the triangle. It depends only on the angle. So let me share my whiteboard again. So he was able to find out that this ratio is 0.64. Okay. And then he was able to just walk up. I mean, this distance they were able to calculate using their usual means. This distance they calculated as something like, say, 100 meters or something. So now it was very simple to calculate. So x divided by 100 is 0.64. So how much is x? It is is 100 multiplied by 64. So it was 64 meters. The height of the hill was 64 meters. This guy was able to calculate the height of the hill without even climbing it. And this was purely on the basis of his knowledge of trigonometry. And you'll see it is not bronze, but sometimes it is the brains that win wars. So wars, and not only wars, but a lot of situations in life need more of brain power than muscle power. Okay. So this little geeky guy said, okay, so 64 meters now, but the big guy was still very, 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 very aggressive. And he said, 64 meters, so what? They'll still fall down and explode right in the face of the enemy. Then he found out. Then he used his equation for gravity and found out the amount of time it will take to reach the ground with when the grenade falls down from a height of 64 meters. He calculated that it will take about 5 to 10 seconds, and the grenade actually would the time which the grenade takes to explode is just 4 seconds. So that means the grenade would explode mid-air, nobody would be hurt, but the Russians would be alerted to the presence of the enemy. That is the Ukrainians, right? So the whole game would just change. So this guy was able to save an entire battalion of 50, 60 people because he used his brains in the right way. So trigonometry is not just to pass exams. Very often, actually, it is used for a lot of practical things. Those practical things we all use every day. Like we know how, the positions of the planets and how the stars move. and a lot of trigonometry has gone into understanding how that happens. Okay, guys. So you must be thinking, is this guy only going to talk about trigonometry? Is he even going to talk a little bit about scratch? Yes, I'm going to talk about scratch also. So we'll just see. Now I will share my main screen, and I've already done a project using the sine function, and I've done something, drawn something called a sine wave. Let's first see this in action. Today I'm not going to show each step, and show you the code each step of the way. Sometimes it can get a bit boring because the code is very simple, but I'll just show you the code in action, and then I will explain how it works. But it's a nice little code. I mean, the effect is really nice and interesting. So what you're seeing here is something called a sine wave. This is something that you may encounter in 8th grade or 9th grade, or you may have already encountered before if you've already crossed those grades. So what we are doing here is we are drawing two sine waves with something called a phase lag. Very big word, sine wave, phase lag, but the idea is very simple. I'll just show it to you. But first of all, did it look interesting and worth looking at? So we'll just look at it again. So what you're seeing on your screen is basically a sine wave, and we have done it completely in Scratch. So Scratch has, you can use Scratch with trigonometry also. It is not necessary that you use it only to move and turn. You can use complex mathematical operations, and they look interesting. It's not that they look boring. They're not like the school textbook, sine 30 equal to this, sine 40 equal to this, what is sine, what is cos. Here you have color. So why not learn trigonometry? Why not have fun with trigonometry in Scratch rather than just keep it in the school, pass exams and forget about it, right? So that's one of the ideas why we do Scratch, is because we want you guys to be hands-on, to learn something in school, bring it into action here, right here in Scratch. Let's now go to the code. Now we have two little scratchy cats. They are making this sine wave. Today they are in the mood for some wavy fun. So many cats, sometimes they will go like this, like this. So we are actually seeing those sine. They are moving around in a sine wave, which is sometimes cats, when they are having fun or something, they'll probably move in this way also. Sorry, bad joke. So what are we doing? We're just setting the pen color to green, which is very simple. Now we are also bringing one of the cats back to this position, minus 200 minus sign, which is to the left of the screen, pen down, erase all, starting from a clean slate. Then what are we doing? Change x by 1. That means the cat, if we remove everything else, the cat would just move in a straight line like this. Now, what are we doing with the y? So you can see that the cat is not only moving in the x, that it is also moving in the y. So we are taking we are setting the y at that particular point. We are taking the x as the input. Suppose the x is minus 250 or 0, then we are taking the x as the input, and we are setting the y to 70 multiplied by the sine. So sine is just a ratio. What is that ratio? I'll just tell you what that ratio is. Sine is a constant ratio. I'll just clear this off again. The sine, like the ratio I just showed you, is a ratio between of a right angle triangle. It is the ratio between it is the vertical divided by the hypotenuse. But what is so special about this? The special thing about this is, no matter what the size of the triangle is, if the angle is the same, the sign will be the same. And that's the beauty of it. So whether the triangle was small, was in a small textbook that the geeky soldier read in his school, or whether the triangle was formed by a big hill in when they were trying to attack the Russians, the sign ratio remains the same. So whether it is a small triangle, so let me say, so that's why this is important, because whether it's a small triangle, whether it's a big triangle, the ratios remain the same. So the angle is closer to you, it's near your body, but the object that you're trying to measure, the heights that you're trying to measure, etc., they're very far. So being here, you can measure a lot of things that are at a distance, just because you know that these ratios are fixed, right? That's the beauty of trigonometry. So this angle, suppose this is a 30 degrees angle. Oh, no, sorry. No, this is a 30 degrees angle. Okay. This is going to remain, this ratio is, now you know that this side of a, you know that this side, wait, this side of a right angle triangle is called a hypotenuse. Very, very big word. I don't know why they come up with such big tongue twister words, which we never ever use. Somebody said, how do you remember this word? So somebody said, try to remember a party. So what is the difference? Try to remember a party and a news. So somebody said, what is the connection between a party and a news? What, and the hypotenuse? He just said high party news. High party news is hypotenuse. So you can remember it that way. It's not a joke, just a way you can remember this word. hypotenuse. Hypotenuse. And the spelling is also slightly complicated, hypotenuse. And this is called the vertical. You can call it the vertical or the vertical and horizontal. So the vertical side divided by the length of the hypotenuse, that is called the sine ratio, and that is fixed for based on degrees. That is not fixed based on the size of the triangle. That is based on the angle measure. Okay. Similarly, the horizontal divided by the hypotenuse, that's called as cos, and the one that we used in our story, that was the vertical divided by horizontal, that's called the tan ratio, sine, cos, and tan. This is something that you will encounter in school also. Okay, let me not bore you further with this theory. Let's go back to our initial Scratch project, and let's see what is happening. So what are we doing? We are using the something called sine function, and for every x, suppose the cat is at x50, then for that x50 50 degrees, we are taking that x position as a 50 degrees, not as a position in the y. So y we are setting to the sine of that particular x position. So if it is at x position 50, then the y we are setting to sine of 50 degrees. Now that x becomes 50, that's how we plot graphs. On the horizontal, it's just increasing normally, and the vertical, that's just the basic principle of plotting graphs of any function. So sine is a function. You put something into it, it gives you out something, like a candy machine. You put a coin into it, it gives you candies. Or a vending machine, you put some coins, it gives you a Coke can or a chips packet. So a sine is like a machine. You put in the degrees and it will give out the ratio. And then that is what we use on the y-axis, and then that's how we visualize that function. That's how we see that function is working like that. That's all we are doing. We are just changing x by 1, using that x as the degrees and multiplying it by 70 to give it, because sine is actually a ratio between 0 and 1. So you have to give it some multiplying factor so that you see a big change. Otherwise, it will just be like this. The same pattern will be there, but it will be so small that you will not be able to notice it. So it's just a scaling factor. Next, you might be wondering, the degrees are from 0 to 360, but this is the stage is increasing from minus 200 to 400, which is a much bigger number. So degrees also circulate. I mean, they don't end at 360. So the angle 361 is exactly the same as angle 1 degrees. 1 degree and 361 degrees is exactly the same. 1 degree and 362 degrees and 362 degrees is exactly the same. So it keeps cycling, rotating. Okay, it does not keep increasing like that. So 0 to 360, that's how the angle increases. So that's how this cat is working. What am I doing in the second cat? In the second cat, I'm giving the y a function, giving y a value which is the sine of its own position plus 100. So it will be a slightly different value. And that's why we will see this change. If both are exactly on the same point, then they will move together and you will not see any difference. So I have just created a shift, and this is called a phase shift. You'll hear, if you do an engineering later on, you'll hear a lot about this phase shift, sine wave, cos wave, etc. Okay, so do remember when you do Scratch, that this is not just fun and games. There's hardcore mathematical stuff also that you can visualize, experiment with. Maybe we'll come back with a video which goes even deeper into mathematics, but this video was only to give you an idea that Scratch can handle hardcore maths stuff as well, and it can connect to what you're learning in school as well. All right, so thanks for watching. I'll say the magic words again: like, share, and subscribe among your friends. Have fun, try to learn things in school, try to implement them in Scratch, and you'll see that learning stuff that you're reading, the stuff that you're reading in the maths textbook in school, is no longer boring. You can use it to create patterns like the ones you're seeing on your screen right now. All right, guys, I'll stop sharing, and that's about it from me. And I just want to show you something small. So I also have a Scratch cat on my t-shirt today. It's actually our Academy t-shirt. If you want to learn Scratch or Unity, Python to make games, and also to maybe later on to build a website and create a web application, Code Wizards Academy does that. We provide classes for you in groups so that you can interact and make friends and work together and have a lot of fun. So do let me know if you want a free demo anytime. Otherwise, feel free, and I'll be very happy if you get to learn something from this video, get to understand something new. And please do, if that is the case, then please do share it among your friends. And then please put a like button and also do subscribe to my video. All right, thanks a lot for watching, and thank you very much for your time. Bye bye.